This is an inelastic collision. So if I started off by saying PI is PF, and we see initially we just have P of the softball, and that's going to equal the P of the softball plus the box, right, stuck together. So there's going to be MS VS is equal to MS plus MB box softball times velocity total. And then what we'll see, what we can see is that this problem has actually two parts. There is a momentum part over here, and then there is an energy part over here. Because this has PEG here and has KE down here. And we're looking for the mass of the box. So, but we don't know the mass of the box, nor do we know the final velocity. But what we do know is that, and I'll do this in yellow so we can keep track, this is energy. We know that MEI equals MEF. Now, immediately you should be saying, wait a minute, you just said this was an inelastic collision. And for an inelastic collision, energy is not conserved. That is correct. For the collision right here, energy is not conserved. But after the collision, this box has some velocity, V total. And from here to there, energy is conserved because it's after the collision. So the energy of the ball is not conserved to the box, but the energy of the box to the box is conserved. So we'll say KE equals PEG, get 1/2 mv squared, and this is m total now. This is m total, and this is v total, is equal to m total GH. Now we had a problem like this before. This right here is H. This, so that's L. This is L cos theta. So hopefully you can see that H is equal to L minus L cos theta, or L times 1 minus cos theta. Okay, so that's our H. So then we can put that here. MGL times 1 minus cos theta. So our M's cancel all the way through, and our VT is equal to the square root of 2GL times 1 minus cosine theta. So this is going to give us our VT. We can go back over here and solve this for MB. If I'll go back to my white here, and I'll say MSVS is equal to MSVT plus MBVT. So then now we say MB is equal to MS times VS minus VT all over MB. Double check, subtract that, and divide. Okay. And then I factored out just to make whatever the math a little bit easier. And I probably shouldn't use that twice. I should have put VT on the bottom there. And of course we got VT from down there. And VT comes out to be 2 times 10 times 2.5 times 1 minus cosine of 30 degrees. And that gives me 2.59 meters per second. So if I plug that in up there, the softball is 0.18 kilograms. Velocity of the softball is 45 minus 2.59, and all that divided, of course, by the velocity total, which is 2.59. And that gives us mass of the box being 2.95 kilograms. If this was 9.8, this might have been a little smaller, so this might have come out to be around 3. So that might have been 3 if we'd used gravity as 9.8. I used gravity as 10. So here I used G equals 10, just to be clear.